Hello and welcome to our webinar for 10 things you need to know about the tmAGC. I'm happy to welcome you today as the presenter of that webinar. My name is Manuel Urstöger. I'm product manager at Track Machines Connected. First of all, I want to say something about also the upcoming webinars, what we are hosting. So in August, we will host a webinar about how digitalization and automation bring process safety to railway maintenance. And in September, we will have some insights on the tmDATS inventory as a service. But about what we are talking today. We're talking about the smart ALC, or how we call it, the tmAGC. It's our automated guidance computer, and it's, I think, well known in the market. And today we want to give you some insights on some key informations, or maybe also some informations what you don't know. The webinar today is for machine manufacturers to get to know all the features, possibilities for your machine, and then also, of course, for maintenance companies and operators to use also the full scope of features on your machine, and infrastructure managers to learn how to work with the system and also get information there. So generally, everyone involved in the track maintenance process. To start things off, here is number 1 on our list from the 10 things you need to know about tmAGC. So the first thing is you can use the tmAGC for tamping machines, track renewal machines, and also dynamic track stabilizers. At the reconstruction machines, as an example, the tmAGC is used for the work along a geometry, and for the DTS, it's the same, and also for comparison things before and after the track. For the tamping machine, it's the main use case, and there we see also today the features. Now moving on to number 2, the tamping methods supported by the tmAGC. The tamping methods is the core functionality which is supported by the tmAGC, and therefore we also wanted to take some time today to speak about them. And what we're looking today is the compensation tamping, the spot tamping, and also the precision tamping. Starting with the compensation tamping. So the measured parameters, what we're using there is the alignment, the cant, and the longitudinal level of the track, which you're doing a pre-measurement. And this method is used when no known target geometry or external reference points are available. The measurement method to measure the mentioned parameters are a normal chord measurement, or you can also do it with an IMU, with a post-EG measurement. There you can do the pre-measuring with up to 100 kilometers per hour, and also flexible in the measurement direction and vehicle orientation because of configuration possibilities with your IMU. And the corrections, what you get out here is a calculated lift and shift based on configurable parameters to compensate the actual geometry. The next thing is the spot tamping, or sprinter mode, how it's also called. This version is used, or this measurement for the spot tamping is used to detect and correct isolated errors on the track. And for that, you need an individual measurement of the left and the right level from your track. The measurement method here is also, again, with the tmAGC, a chord measurement, and the corrections then are a separate lift calculation for both rails. Last but not least, the precision tamping, which is the most correct version for tamping, because you bring back the track to the design geometry with reference to the original track position. What you're measuring is, again, the track geometry, the level, the alignment, the cant, and then also external reference points with the markers, like with the RTG. And there you measure the horizontal and vertical distance, and also the super elevation on the track to compensate also here the difference between the design and the nominal value. The measurement methods used there are total station, continuous measurements with a manual trolley, loaded measurement with a measuring vehicle like an EMSAT, or also the high-speed loaded measuring with the tmRTG. So when we are talking about the EMSAT, we are around speeds from 5 to 6 kilometers per hour for the pre-measurement. With the RTG, we are up to 100 kilometers per hour. And with the trolley, you're around 4 to 5 kilometers per hour. And the static measurement is around 3 kilometers per hour. And yeah, the correction then, as said already before, it's a correction based on a target geometry and design offset to the fixed points, to correct the values. The third thing we want to talk about today is the autosync function. The autosync function automatically synchronizes the tamping machine during operation using an optical track gauge measurement system. The benefit here is an automated synchronization without manual intervention. So the track gauge is recorded as additional measurement value in the measurement file, and the export of the measurement file includes the track gauge for the tmAGC. Then the tamping machine, equipped again with an optical track gauge measurement system, continuously provides track gauge values during operation. And the synchronization there is done at the start of the measurement and continually resynchronized. I just have seen that someone raised his hand. I just want to ask you to remember your question for after the webinar, and then just ask the question after the short presentation in the Q&A part of the presentation. Thanks for that. So the fourth thing we want to talk today is the obstacle controller. So with the obstacle controller, you can consider physical obstacles in the correction process. There you have the working mode extension, where real-time obstacle visualization is possible during work mode, and operation then automatically, while the operation, you're automatically locking the working units with configurably safety offsets, and you can also on the fly edit the obstacles, and also the edited obstacles will be automatically saved then. So, and of course, when the obstacle is blocking some of your working units, you can always manually override if you think, okay, this one is not blocking my working unit, and you can still use it. And it can, of course, also be used together with sleeper detection, as an example, a TIE finder. The whole obstacle controller comes also with an editor. And in the editor, you can define your obstacle files. So you can create, edit, and visualize obstacle files in a table and in a graphical view. As you can see here in the presentation, it's an interactive editing of obstacle positions and affected working units. And then, of course, you see also in real time the display of the impact from the obstacles. So what aggregates from your machine, or what working units are blocked. You can also, of course, add then synchronous points for the kilometer jumps, and if you have a geometry available, you can also automatically load it to that. Our fifth topic today is to eliminate the memory effect of track works. We have therefore two possible solutions. One thing is the standard overlifting on the left, and the other one, the differential overlifting on the right. Starting with the standard overlifting, it uniformly applies an uplift factor, so it's a 1 plus c factor, to all deviations, both long wave and short wave, based purely on the measured deviation and empirical coefficient c. The drawback here with the standard overlifting is that long wave static settlements are also overlifted unnecessary high. So on the left side, you can see if you have that big failures, there will be, of course, also lifted unnecessarily high with that standard overlifting feature. Therefore, we implemented the differential overlifting, which you can see on the right side, which separates short wave and long wave components. So a moving average identifies long wave trends, so the yellow line, what you can see here. And overlift applied only to the short wave deviations, which are the purple arrows seen here. So, and the coefficient C is, to do that, dynamically adjusted during tamping. So the benefit here is really a precise correction with reduced ballast wear and better long-term alignment. So the differential method targets only shortwave errors, avoiding excessive lift on stable sections and improving alignment sustainability in the end. The next topic, we do precision tamping without pre-measurement campaign. That's our point 6 today. With the KAL or KHR support, we have a one machine operation, no need for extra survey crew in advance, which saves time and labor. It's flexible regarding usage, so it supports both laser-guided tamping for the compensation method and fixed point surveying for precision tamping. The limitations we have, of course, also with the KHR scanner, it can be only used in straights, but with the Curve Laser, you can also work in turns. And you also have, of course, a reduced work speed while tamping due to the additional measurement procedure, what you have to do. If you want an upgrade of any feature what we have talked until now, just contact also your local Plaza service partner for detailed information regarding the possibilities also on your machine. Number 7 is a very handy feature. It's the check of the design geometry against the EN 13803. And it automatically checks while editing the geometry in the geometry editor. And it is done based on assigned speed classes, and you also have a solve functionality, which you can see here and here. It automatically proposes you a solution how to change the geometry to be according to EN 13803. And it can be activated or deactivated based on the needs for your construction site, because if you don't have the need for compliance to EN 13803, it can also be done if it's needed. Yeah, you also have the possibility to do it. And the visualization is in the edited dialog like we see here, and also in a tabular view. Coming to point number 8. While working, maybe the time to do the construction site is always not long enough to do everything in one part. So there must be some functionality to have some ramps for intermediate work stops on the track. And yeah, so this feature can really be used if the work has to be stopped and will be continued afterwards because you have too short track closures. What is the feature enabling? So you have a configurable ramp ratio, which defines the ratio to generate a smooth lifting and shifting ramps for the temporary track opening. When you pause them, you will get and save the progress. You will get a new FAIR file, which is containing only the missing correction value for the paused ramp area. And when you then want to start again working, you resume at the end of the ramp, you restart work from start of the end ramp to ensure seamless continuation of the track correction. Now already coming to the 9th part of our short webinar today, it's the new features of the production release 2025 to give you a little bit insight what we have now new on our smart ALC or tmAGC. It's on the first slide, we want to show you the curve laser improvement or tell you something about that, and also some work of life improvement with tooltip information. So the curve laser improvements in the work mode, and so now for tmAGC is now able to start working with the curve laser while already working without adding a ramp. This was not possible before, so you added then additionally a ramp which was unneededly overlifting your track here, and therefore we implemented that this is not happening in the future and you don't change the track unnecessarily. And also the second thing what we have here is the tooltip improvement. So the hotkeys now are shown in the button as a tooltip information for all buttons we have on the tmAGC where such a shortcut is available. Also for expert users, this is maybe most of the time known, but for new users for the smart ARC, this is very handy. Also, what is new is measurement run improvements. So for compensation with super elevation geometry, the default transition type can be selected as it was possible in the Win ILC, and it does not affect the start and end ramps now. And the ramps created for constraints are now also adjustable in the compensation dialog. You can see here with that button. What we also have is the TMOS-based tmAGC system protocol and a CSV import for third-party measurement systems. So the TMOS-based tmAGC system protocols shows the shifting and lifting values applied and also the markers set while working, and enables them to show this information together with a tamping protocol from a TMA2 or other products which are available on the machine, and to have a complete view about the information what has been done. So not only the positions where have been tamped from the TMA2, what obstacle has been detected, but also the lifting and shifting values applied along the track in one combined job protocol. And the next thing is the import of measurement files as CSV for measurements from third-party systems, which can be activated in the program settings, and enables here also more integration and more possibilities also for the customers to use also other systems together with the tmAGC. And last but not least, the hacks. So the hacks are now some information what you maybe don't know but can be very handy. So as an example, you have the legend for charts, what we want to show you here. So you can see here, you have here a chart, and on that chart you can fade in and fade out chart lines, which is especially beneficial if you want to load a second measurement into your tmAGC to don't get overwhelmed with the amount of charts, so you can separately fade them in and fade it out for a more detailed view on the things. And the last hack what we have is the optional view of the lining and super elevation and the longitudinal table. So you can switch between a horizontal and vertical display of the tables by pressing the control key and double clicking on the sheet tab at the bottom. So they will be then presented next to each other or above and below to each other. So to your needs, what you like more. But this is an easy change, but you just have to push the control key and double click on that tab, and then it will be changed automatically. Can of course always be rechanged with the same hack. So coming to the conclusions. tmAGC was introduced in 1996. It's used in over 109 countries worldwide on over 2,000 machines, and the availability, what to say, we're turning 30 next year with that product, so we can say it's a long-term available product. It's an intuitive operation for all users. So you have the touchscreen operation, you have the tooltip information, you have all the things which really helps you while navigating the machine through the working process. And it prevents operator error damages with the obstacle controller, what you can use additionally with the autosync functionality. You really can here eliminate also mistakes by using these features and helping yourself while working. And of course, it also enables accurate fault localization, as an example with the spot tamping feature, to have here really detailed information also about the left and right track, and localize here also, local arrows. If you have any questions on upgrades, add-on upgrades, or also the yearly production release upgrades, for both of them, we want to ask you to go to your Plaza and Robo service partners and get in contact with them, ask them about the possibilities on your machine. Depending on what version you have on your machine, there are different upgrade paths and different to-dos to get to that state. So I want to say thank you for your time and listening to the webinar. And now I'm here for your questions. To get it clear, please write the questions in the chat and then we can answer it. Okay. Yes, now I found the questions. It's also my first webinar in that thing. So from Gerhard, the first question was, how flexible is the EN 13803 compliancy check? Can it be also customized for national or local standards and beyond the default speed class settings? Yes, it can. Of course, it has to be checked what has to be done, but we are, of course, the EN 13808 is according to the EN 13803. But we have also done a customized solution as an example for a customer in Poland, where we also did extensions, especially for that customer, and they have been implemented and used. Any other questions? If there are no additional questions in the chat, I would say to you, thanks for your attention. You have my contact details on the last slide on the presentation, which will be shown now. So if you have any questions, also please just call me or write me an email. Also get in contact with your local partners. We are happy to answer all your questions. The webinar will also be available on YouTube if you want to have a look on it again. So thanks for your attention. I wish you a nice rest of the week and have a nice day and see you again. So thanks and bye-bye from my side.